Okay, here's the solutions to homework set number 2 for ECE 341 for the summer. The first problem looks at how many different ways can you deal out 13 cards. In this case, order doesn't matter, so that'd be combinations. 52 choose 13. That's 52 factorial over 13 factorial times 52 minus 13 factorial. Or on an HP calculator, that'd be 52, enter 13, and under probability, combinations. Permutations is order does matter, combinations order doesn't matter. Gives you 635 billion different hands. Problem 2 then looks at what's the probability of having 9 cards in one suit. In that case, the number of ways you can get 9 cards in one suit is there are 4 suits, choose 1, 13 cards in that suit, choose 9, and 39 cards in other suits, choose 4. Got an HP calculator. The way you do that would be, let's start out, 4 choose 1, which is just 4, so you don't really have to do that. 13 choose 9, multiply, 39 choose 4, multiply, 235 million. The probability then is this many hands have 9 cards in one suit, 52 choose 13, is how many different bridge hands there are. Take the ratio, that's the probability. And if we give it more decimal places, display fix 07. There's a 0003704. Or take the inverse, 2,699 to 1 odds against. Problem 3. What's the probability of having no points? Well, there are 16 cards that have points. That's the jack through ace. 36 cards that don't have any points. So of the 36 cards that have no points, choose 13. Of the 16 cards with points, choose 0. Multiply it out, I get 2.3 billion. The probability then is how many hands have 9 cards divided by the total number of hands. It's 0.003 or 274 to 1 odds against. Can happen, not very likely, but once in a while it does happen. Problem 4. Fighting with the mouse here. In 4-card poker, you're dealt just 4 cards. Compute the odds of getting 2 pair. So the number of hands in 4-card poker is 52 choose 4, 270,000. The number of hands with 2 pair is there are 13 values, ace through king. Pick 2 of them. Of the 4 cards, the first one, say look up have jacks and 3s. Of the 4 jacks, choose 2. Of the 4 3s, choose 2. Gives you 2808. That's the same number we came up with when we did enumeration. That's kind of one way to check your answer. If it matches the enumeration, you did it right. The probability then is the number of hands that are 2 pair divided by the total number of hands, 0.01. Number 5, my mouse isn't working. Number 5 says, how many hands have a single pair? Again, we found that using enumeration. It was 82,368. I can get that same number using combinatorics. There are 13 cards for X, choose 1. There are 4 cards of that value, choose 2. Now, of the 12 suits, or 12 values that are not X, choose 2 of them. That gives you Y and Z. Of the 4 Ys, pick 1. Of the 4 Zs, pick 1. And it gives you 82,368. Same number we got by enumeration. And the probability then is the same thing we got, 30% chance of getting a pair. Now this is the advantage of combinatorics. I don't have to go through every combination. I can sit there and calculate how many different hands and calculate the odds. Problem 6 is repeat using Monte Carlo simulation. So in this case, I'm going to shuffle the deck. that's what this part of the code does right here. I'll take a deck of cards, shuffle it, and then sort it. When I'm done, the deck is my shuffled value. It's the numbers 1 through 52 in a random order. The first 4 cards are my hand. To determine the value, I take the hand mod 13 that gives you 0 to 12, 0 to 12, plus 1, 1 to 13, 1 to 13. The suit, and again, this really should be stealing. It works for every card except for the last card, 52, but get the suit, but we're not using suits, so it doesn't really matter. Let's see, what am I doing? Okay, and then once I have my 4-card hand, count how many aces, how many 2s, how many 3s, sort in descending order, and so this is the frequency. N of 1 is the highest frequency, how many of them there are. N of 2 is the second highest frequency. If the highest frequency is 2, and the second highest frequency is 2, I've got 2 pair. If the highest frequency is 2, and the next highest frequency is 1, I have a single pair. Then display how many pairs I got divided by how many times I ran the Monte Carlo simulation. That's the odds, roughly. And again, that matches up with what I calculated. Not exact, calculations are exact. Monte Carlo gets you close. Problem 7 is, what's the probability of getting 4 of a kind in 4-card poker? Now there's a couple ways to get 4 of a kind. I could be dealt 4 of a kind. I could be dealt 3 of a kind, draw 1 card. I could be dealt a pair and draw 2 cards, or no pairs, draw 3 cards. The first case, the number of ways of being dealt 4 of a kind is there's 13 cards, pick 1. 4 cards of that value, pick 1. So there's 13 ways to get 4 of a kind. And once I have a 4 of a kind, the probability of getting 4 of a kind is 1. For 3 of a kind, the number of ways of getting 3 of a kind is 13 values, pick 1. Of the 4 cards of that value, pick 3. 48 remaining cards, pick 1. So there's 2496 ways of getting 4 of a kind, or getting 3 of a kind. The next card, there's only 1 card that matches. Out of 47 cards remaining, pick it. 2 of a kind. There's 13 cards, pick 1 suit. That's the match, like jacks. Of the 4 jacks, pick 2. Of the 48 other cards, pick 2. And in this case, if I have two pair, doesn't matter, I'm going to throw out the other 2. So it doesn't matter if the other ones match or not. Once I have 2 of a kind, there are 2 cards, like 2 jacks, left in the deck. Draw all 2 of them. Divided by the number of ways I can draw 2 cards from 47 cards remaining. 000925 is the probability of getting 4 of a kind, starting from a pair. Then a high card. The probability of getting a high card is there's 13 different values, pick 4 of them. The first value, pick 1. Second card, like the 2s, pick 1. 3s, pick 1. 4s, pick 1. 183,000 different ways of having no pairs. The probability of drawing to a 4 of a kind is there's 3 jacks left in the deck, draw all 3 of them, divided by 47, choose 3. Now putting it all together, if I start at 4 of a kind, I'm dealt 4 of a kind, I'm going to get 4 of a kind. If I'm dealt 3 of a kind, there's a probability to go from 3 of a kind to 4 of a kind. If I have a pair and high card. Add them all up, that's the total probability of getting 4 of a kind using single draw step in 4-card poker. I can check that using Monte Carlo. That's the last problem. I'll write a program to play 4-card poker. So here I'm dealt out the hands. And then sort based upon the frequency. So this is the frequency of each card. Sort based upon frequency, and then check if the most frequent card, there's 4 of them, I'm done. Don't do anything. If the most frequent card is 3, throw out the last card, draw a new one. If the most frequent card is 2, draw two new cards, Most frequent card, there's only one of them. Draw 3 new cards. And then recount how many, the frequency of each card. And if I have 4 of a kind, increase that. So that's a Monte Carlo simulation. I ran it for 1,000,000 times, and what I wound up with is 0.000643, or 643 4 of a kinds out of 1,000,000 hands. Calculated was 0.000554. Yep, fairly close. And that's the advantage of Monte Carlo. Knowing nothing about combinatorics, I can calculate the odds roughly. The advantage of combinatorics is I can get there exactly, and it doesn't take 1,000,000 hands. So even after 1,000,000 hands, it's not exact. And 1,000,000 hands took, so where's my talk? Took 77 seconds to run. So that's homework set number 2 for ECE 341.